Hello, and welcome to the AspenTech luncheon here at the ARC conference. My name is Chris Williams. I'll be presenting today with my colleague Bert Hedema. A little bit about me. I have been in this space for over 20 years. I initially cut my teeth working at IBM with artificial intelligence on the Watson project, and also working with other technologies like Maximo and other applications within the Tivoli suite. I then ended up working with KBR and worked in the Middle East in some very dangerous places, deploying technologies around ERP and EAM, as well as sensor technologies that helped with logistics and improving the overall infrastructure and quality of life there. And then working here at AspenTech, I've been with AspenTech for 4 years, and it's been a fantastic journey. And I've been married with my wife of 20 years, and we have 4 children. I graduated from the University of Texas at Austin with a degree in physics and a minor in philosophy. My parents thought I'd never get a job, so I've proved them wrong. I've had a few, and I spent 4 years in the Marine Corps as a communication specialist in radio and satellite. Bernd?
Thanks, Chris. My name is Bernd Hedema. I'm a solution consultant for AspenTech. I've been with the company for 2 years now. I've been applying our data analytics technology to processes across various industries and helping customers gain amazing value from their existing process data. Before joining AspenTech, I was an advanced process control engineer for 10 years, and I originally graduated with a degree in chemical engineering from the University of Stellenbosch. I'm really excited for you all to join us today, and I'm now going to hand over to Chris, who will take you over the business value that you can get from improving your process health.
Thank you, Bernd. So, you know, AspenTech, we've been a world leader in asset optimization and capital intensive industries for a long time. You know, we have a long portfolio and library of proven technology where we work with all of the leaders in major industries, and they've helped drive our innovation forward. 2,300 customers plus worldwide across many different verticals, plus the ability to leverage those relationships and bring some of those customers in as employees to help make our industrial expertise very robust. We have highly experienced people in our organization and in our customer base. We have over 100 PhDs. We've trained over 6,000 users per year. We have, $50 billion in annual value created through our solutions, and we are focused very highly on a concept, and you'll hear it throughout this presentation, around safety, sustainability, profitability, and innovation. The safety and the sustainability pieces, you got to keep your people safe. You have to keep the planet Earth clean. Focus on your business profitability, and how do you take those 3 elements and make them better and more advanced through innovation. That proven value together, really helps improve margins and making your operations safe. In that time that we've been in business for over 39 years, we have a history of firsts. We have created the world's first flow sheet simulator, the world's first desktop planning tool for refineries, model and predictive controllers, adaptive controller technology, concurrent conceptual engineering workflows, unified planning and scheduling tools, hybrid modeling, and now, as of this year, the AIoT hub. I mean, really just a very robust list of solutions and technologies that we've provided to the marketplace that have really brought us, helped us build a foundation of innovation, right? We invest heavily in this. We hold over 120 patents, and we have an exciting strategy for industrial AI that we believe will generate new levels of value in the industries that we serve. Lastly, we want to establish global partnerships with advisory partners, value-added resellers, and implementation service providers. Some of those names that you've seen before. And why do all this? Why even tell you about these 4 pillars that you see on this slide is because we understand that it's not just the technology. The technology is extremely important. How do you manage the data? How do you shape it? How do you leverage the tools and technologies of the 21st century and artificial intelligence and machine learning? Couple that with advanced analytics, looking deep into the data to provide you answers to some of your most troubling and persistent questions. Coupling that with the human X factor, that third or fourth dimension of the data, the industry experience, the industry expertise, the domain expertise, the ability to see problems based on experience that are not grounded in data, but grounded in how your 20 or 30 years of running your business or even longer come to play. All those things together bring us to the advent of industrial AI. It is a new horizon. It is a new way of looking at problems, coupling technology and expertise together, plus our long-term history of building innovation and bringing those skills and those learned people to the forefront to provide value, not only to our company, but to the world. So that's great, Chris. Awesome. Thanks for telling me all that. But why does it matter to me? Is probably what you're asking. And I'll tell you why it matters to you, because I think that it is important that we communicate with many customers on a global basis about the challenges they're encountering, particularly those that have become more acute in the last 12 months. The rise of COVID, fluctuations in oil prices, and then just the daily challenge of being sequestered and trying to figure out how you're going to run your daily life. All those things build on your people, on you, and on your ability to do your business. So change is the name of the game for everyone. Specifically, though, a change in operating plans and possibly new courses of raw materials. So for some customers, this has put them in somewhat of an uncharted territory, right? And they are unsure what risks they're introducing to their equipment and their processes. And that's a part of what, it comes with doing your business. But during this period of VUCA, it's at levels that are, in some cases, unimagined and unplanned for. But to that, customers have to make these changes because they may be experiencing big swings. The demands may be there like never before. And even a year later, there's a idea of what we think things are going to be. And it's hard to start projecting that forward, especially now. The future is more cloudy than ever. But in the past, our customers have made more leeway to plan, have had more leeway to plan for these unplanned events. Today's environment has them looking for ways to be more agile, right? And how do they make changes, whether that is shifting operations around, making, around locations, or perhaps pivoting products by facility. So remote operations and limitations of on-site personnel are still in play. A lot has been done to adapt this, but many are seeking ways to further ensure that they are at a high rate of availability and are migrating and mitigating these risks. So, and of course, all this is going on while customers are being expected to reduce their spending by improving the safety of their people in the face of this increased risk, and even look for new efficiencies in emission reductions, right? Back to that inception concept that we talked about. How do you keep your people safe? How do you reduce your impact on the environment? How do you maintain your proper profitability? And now how do you innovate and move forward and create an agile environment where you are quicker in your responses to the changes in the marketplace, right? So let's just take a look, right? So changing operating plans and new feedstocks, increased risk of equipment and process degradation. We know this. So what do? right? When the demand swings are creating the need for agile production shifts based on more data-driven decisions. And the increased need for remote operations, are you ready? Is Teams and Zoom enough? Do you need VPN, Slingbox? Like, how are you going to manage that? And on top of all that, you've got the need to adjust to the market volatility while minimizing your operational expense. So I'm not trying to paint a dire picture here, but I think everyone lives and breathes it every day. We have to be sturdy and agile, and we have to be able to see what's coming, at the same time manage and maintain a stable timberline, if you will, for our business. So let's dive in a little bit further, okay? Let's look at the impacts of these challenges, and let's take these things apart piece by piece, right? So first step, for many, the first impacted area to come to mind is often the equipment, right? So surges in supply and demand might mean running faster and hotter, right? Or slower, even shutdown, all leading to decreased equipment availability and downtime. So anytime equipment is shut down more than it's planned, it impacts the reliability and safety. So facilities are designed to run continuously, right? And at a certain rate. So when you venture outside of these operating norms, the impact is not always fully understood. One point that does not come up as often as equipment reliability is process variability. Similarly, just as the impact on equipment is not known, neither is the impact of process stability, as in its ability to keep all reactions and the quality of the final output in check. You know, so the life of consumables such as catalysts can be impacted, and given that these are new operating conditions, it's completely uncharted territory. So lastly, right? And then lastly is the impact on the system decision agility customers are going to want to mitigate with more data-driven decisions. But if these scenarios are never seen before, how will you do this, right? How are you going to be able to plan and project against something that you haven't accounted for in the past, especially in this environment? Well, what we want to discuss today is this middle layer of the process impact. AspenTech's APM suite is the only solution available designed to tackle the specific piece of the puzzle and do so using existing data sets and the expertise and the domain knowledge of customer process engineers, right? So this is the realm where we are taking the technology, we are touching it with your process experts and your resources to provide a solution that is one of a kind and stands on its own. With that, I will hand over to Bernd. Bernd?
All right, so before we delve into AspenTech's solution for handling process instability, let's quickly look at an example of how things are currently done. So we have all these losses, and they result in scrap costs due to off-spec product, production rework cost to resolve off-spec issues, as well as margin losses due to sale of a lower grade material as opposed to the required grade. And so over the last 30 years, manufacturers around the world have tried to reduce the cost of poor quality. One great example is in the 1980s, Motorola gained prominence with the monitoring and process improvement technique that is now known as Lean Six Sigma. With this approach, key variables were closely measured and acted upon whenever they violated some statistical limit. Although this approach to waste reduction had its merits, there were some major drawbacks though. This was specifically applicable for the process industry, where we have hundreds of process variables, of which many are correlated. Secondly, we also have a lot of unaccounted for causes of variation. These are difficult to pinpoint, and it's difficult to know what are the real causal relationships between external sources of variation and the output of the process. So if a given operator wanted to monitor the process by looking at individual trends, this phenomena of information overload would occur. And as such, it would be very difficult for an operator to, first of all, know what the process state is by looking at all the input variables. And then secondly, know what to do if things are going wrong. So this led to operators really operating the plants reactively instead of proactively. So what can we do about this? Well, ProMV helps us here. First of all, ProMV untangles the messy data that we have. So we take the historical data with ProMV, we apply our advanced techniques in ProMV to this data. That gives us process understanding, and we can apply our domain knowledge to this process understanding that we're getting from the model, and then we can deploy this online. And because we're now alerting in real time with a model-based approach, operators suddenly have much fewer things to look at. And when there is a problem in the process, suddenly they can get actionable information that is of high resolution so that they can take proactive decisions instead of waiting for alarms to occur in the process. Now, you might say to me, well, this looks really fancy and difficult to implement. And we do face that, where there are common misconceptions and limitations that people face when trying to deploy a new technology like this. They can basically be broken down into two parts. The first part is all around asset management prerequisites and skills requirements. Here, the argument is that it'll take years to put a program in place and put an organization around this kind of approach. And we need to train up a bunch of data scientists in order to achieve these kind of benefits. We find, in fact, that this is not true, and I will demonstrate a little bit later. The second part is around data readiness and data integration. There's an argument that says, well, the data that we have in processing industry is messy, it was passively collected, and we need to implement all of these systems around the data in order to contextualize the data and build fancy pipelines. Well, with ProMV, none of that is true. ProMV was actually developed by process engineers and control engineers for process engineers and control engineers, so that they can leverage their existing domain knowledge as well as the existing historical data in the data historian to get actionable information, to understand the process and optimize it. So there is no need for developing fancy data pipelines. There's no need for hiring a big data science organization so that we can figure out how should we look at data. All of that has been done. And with ProMV, the existing workforce of process engineers and control engineers have a tool at their fingertips that they can use to expand their subject matter expert knowledge. So let's see how some of our customers have been able to do this. Well, first of all, we have an example here from Braskem Idesa. They were experiencing excessive reactor fouling that led to shorter reactor cleaning cycles. Now, each of these cleanings, when they had to clean the reactor, took 15 days. This is obviously a significant impact on the overall availability of the reactors. After a 2-year effort, they were able to reduce or extend the time between cleaning by 20%. They did this using traditional statistic process control techniques. However, they did realize that there would probably be some room for improvement. So what they did was they took Aspen ProMV and they analyzed the data using the workflows in ProMV, and within a couple of weeks, they were able to establish multivariate conditions that accelerated fouling. And so by addressing those issues and optimizing the way that they ran the reactors, they were able to increase a further 20% in terms of time between shutdowns. This is tremendous if you think about the fact that within a couple of weeks, they were able to get the same amount of benefit that they did from 2 years of traditional application to data. Another example from Braskem, which is also somewhat similar to the previous one in the way that they approached it, was there was a process problem here. The process problem was really a breakthrough of a light molecule, so propane to a butane stream, and that caused flaring in the downstream unit. And so they did an independent study on this propanizer and tried to understand, what do they need to do? Because this is obviously a very expensive problem to be facing. And so what an independent study showed them was that they needed a second reboiler for this column to work efficiently. However, once they put the process data in ProMV, they were able to pinpoint that the problem wasn't really that they needed a bigger reboiler or a second reboiler. The problem was the way that they operated or controlled the distillation tower. And so ProMV identified which tray was truly the specific tray temperature, and also at what set point that tray should be run in order to minimize breakthrough while staying on quality on the top product. Now, this is an enormous benefit to Braskem because not only did they cut down on their environmental losses through flaring, they were able to save more than $1 million a year in flaring losses, as well as stopping a capex project from having to be done in order to retrofit the column. Great success story. And in both of these cases, Braskem took historical data, they needed to solve a problem, and they applied this advanced data analytics to that problem and got quantitative insights. The next example shows how a big petrochemical company used not only the offline software, but also the online software to run their compressors more efficiently. So compressors are notoriously expensive to run because of their high energy demand. And so if we could build a model around compressors that adapt to the real world circumstances that constantly change, so load changes constantly ensure that the compressor has to run in different zones, if you will, then obviously one could gain great savings. And so what this company wanted to do is they wanted to reduce their steam consumption on one of their most important compressors. And so what we did in ProMV is the customer took a lot of data, put it in ProMV, identified different zones, let's say call them pseudo steady state zones, and by running the ProMV optimizer, they were able to find a better operating zone that yielded a 5% reduction in steam consumption just off their historical data. Then after putting it online and iterating, putting those changes in place, evaluating the data and optimizing the process, a further expected 5% improvement is realizable. So imagine if you can do this across not only one compressor, but across all the compressors on site. Finally, I want to end off with an example from ADM. ADM is an international agricultural products company, and they wanted to reduce the amount of lab sampling done for one of their processes. And the problem here was that often lab samples are taken sporadically, and it takes a couple of days for these samples to be analyzed and the results to come back. And so what they wanted to do is they wanted to cut down on this wait time, because whenever something did actually go off spec, it was way too late to make a change to the process to get the product on spec in time. So not only was there a massive wait time, but once things were identified as incorrect, it was a significant impact to the business. And so using ProMV on 150 odd process variables, they were able, within a couple of weeks, 4 weeks to be exact, to produce a model that they deployed online in ProMV online. And this model, what it does is it predicts in real time what the end product quality is going to be like. And so this allows them to with confidence, produce when things are on spec. But when the online model flags that there is something wrong in the process, they can immediately make changes without having to wait 2 or 3 days and risking off-spec product to customers. And that's all just because of using historical data, applying domain expertise, and then deploying the model online. So in summary, we saw how Chris discussed how we are really facing unprecedented moments of change, and that there's all this change really drives the business in a different direction. And so a key to being able to meet the business challenges of today is really reliability. Reliability both on the equipment side as well as the systems side, so reducing risk, and then also process. And so what we showed you today was how ProMV can really address that process issue. Gaining process health is a paramount requirement if we are going to meet the needs of today's business environment. We showed you some examples today of how some of our customers were able to get great value from ProMV. But we do want to encourage you, go onto aspentech.com for more stories, demos, and examples. You will see quite an expansive library of use cases there. We'd love to get in touch with you and talk to you about those in more detail. Finally, we want to encourage you to also see our Optimize 21 conference. We have a deadline of February 15 for papers where our customers used our software to great success. If you are one of those customers, please do go online and register a paper, and we will be in contact with you. If you don't have one of those, this is a great event to be inspired. So come and join Optimize 2021. It is a massive event. Industry from across the entire globe is going to be there. This year, of course, it's not going to be in person, but you will find that in the virtual platform that we'll be using, it will be interactive, it will be informative, and you will find great value from it. So that concludes the session today, and I hope you found it really valuable to you. Please stick around because we're going to do a question and answer session now. So please feel free that if you have any questions, me and Chris will be here and we will be able to answer those for you. Thanks, and have a wonderful rest of your conference.
So Chris, Bernd, thanks very much. So everybody that's in attendance today, so I'm Peter Reynolds. I'm with ARC Advisory Group and an analyst and consultant. And I'm going to moderate the Q&A session. So I encourage everybody in the next 16 minutes before we have to close, please submit a question via the Q&A button at the bottom of your screen. And it looks like if I could start, I can see a question here already. So you mentioned a couple of really interesting use cases. Some of them were in the petrochemical industry. And I guess this question could go to either Chris or Bernd. Do you see this applicable, solution applicable to other industries such as pharma or mining or perhaps industries that are not that have got different data structures? What do you think?
Yeah, I can take that one. Absolutely. So the solution was developed to be applicable across the entire value stream. So whether that's petrochemical or specialty chemicals, we have pharmaceutical customers also using the solution. And really what sets it apart is the fact that you can use it both on your continuous processes as well as your batch processes. So it's got some really powerful workflows and technology embedded in it, so that you can really apply health monitoring across your entire value chain and not just a certain section of it.
No, that's a great answer. And I would say too, just to extend on that we've seen ProMV employed in very creative ways as well, across the value chain, across markets, across the world. So it's a flexible technology, and again, it's kind of what we heard in some of the earlier sessions around data and process and expertise and putting those together.
Yeah. So there's another question that's come through. So what about different roles in industry? You mentioned assets and process. Is the ProMV tool or the APM solution simple and intuitive enough that it could be used by roles other than just process engineers? Like, for example, is this a maintenance engineer's tool or an operator's tool?
Yeah, it's a good question. So there are different roles associated to ProMV, right? As is there to some of the other tools in our suite. Primarily, the people that will be building the models, those will be people with deep domain expertise on the process side. So those will be process engineers, control engineers, technical people. The end user of the model, though, once it's online, that is an operator. That'll definitely be someone that sits behind the panel and wants to monitor their plant. But we need to make a shift in industry. Reliability engineers aren't the only people that are responsible for reliability. It's the process engineers and the operators that are responsible for reliability. And the reliability engineers are responsible for the process. So unless these functions come together, there's absolutely no hope for us to really stabilize process and equipment health. And so these tools are developed in such a way that the end user can be someone necessarily for this example, the intended user.
So this is another question that's come in from an anonymous attendee. It says that ProMV, is this based on machine learning techniques for prediction, or is it other? Can you talk about that?
Yeah, certainly I can talk about that. So no, it's not machine learning. And the reason for that is machine learning is probabilistic in its nature. And when you want to take actions, these actions could cause serious events. If you take the wrong action because you're working off of a probability, then what could happen is you can blow up the plant. You don't want to do that, right? So you want a mathematical model, but it must be a mathematical model that really describes the entire system. And that's why ProMV uses a subset of AI, if you want to call it that, called principal component analysis. It's been around for years, but it's just a very small part of the whole.
Yeah. Another question here from Helen Dodson. The question is, do you have success stories from batch processes, and does ProMV operate within the existing IP21 server environment, and is additional hardware required? Would you please share information about the architecture solution?
Right. Yeah. Chris, do you mind if I take it again?
No, go ahead. You're on a roll.
We'll have more for you, Chris.
That's okay.
So yeah, so we've got plenty of examples in batch. In fact, ProMV's original roots came from batch. ProMV was really kind of built in the batch environment. And so we've got plenty of examples where our customers have used those, and we can absolutely connect afterwards and share those. With regards to the architecture, yes, it links into the existing IP21. and APM environment. But if you wanted to install the online server, it would be a standalone server, an extra server, because you will probably want to deploy many of these process health monitors across your entire value chain, right? So you want a dedicated server for that, similarly to which you will have a dedicated server for your equipment reliability and for your IP21 data.
Okay, here's another good question. And we've got about 10 minutes left, so please keep the questions coming in, everybody. Can APM be offered as a SaaS outcome-based service?
Can APM be offered as a SaaS outcome-based service? Well, you know, we are putting together, you know, our IoT hub, which you saw in one of the slides, where we are building these type of SaaS capabilities and allowing for working with your data scientists and others to put together custom solutions for you. You know, typically our solutions are installed on-prem, they're installed in the cloud, and we have really focused on delivering that solution to our customers. But we continue to innovate, and we, with this new offering, we are looking at new ways of bringing our solutions to our customers.
Okay, yeah, thanks, Chris. Okay, here's another really good question. Do you have an ecosystem around your APM platform? Meaning, do you have it open to developers and end users for additional intelligence? And maybe address that in two parts. One about the ecosystem, and the other about the openness.
So right. So again, this kind of points back to our AIoT hub, our ability to bring in and work with our data science allies within our customer base, within our partner base, and allow that type of sharing of information to bring forward technologies and solutions specific to what our customers are asking for. You know, there are many different flavors of openness. We have typically been, you know, solution based and not platform based, and so to that, again, we point to the AIoT hub to provide, to begin providing some of the things that we're hearing out there that we can address as customers bring to us some of the solutions that they want provided.
Yeah, so maybe to add on to that, I think it's important to think about what you want to solve, right? If you are trying to mitigate process health issues and reliability issues across your entire value chain, what you really want are point specific products that solve those let's say 80% of those problems, and that's what some of the existing products do. Now there is a use case where some very specific things need to be addressed, and that's where you will go to the AIoT hub in order to get those kind of advanced methodologies or workflows out there that some data scientists would require.
Okay, so I have a question then. So the AIoT hub, is that some information that you'll have available in your booth in this conference?
Yeah, come visit us at the conference. We have lots of information around these different innovations that have come out, and we are, you know, our self-optimizing plant story. We can talk to you about that. Talk about how we are really looking at sustainability and focused on that. You know, we have joined the Alliance to end plastic waste. We are very focused on that. So there's a series of things that we're doing and that we're advancing. So come visit us at the hub. We'll talk to you about it. Yeah.
Yeah. Well, thanks for that perspective, because I know the number of years we've been running these ARC forums in person. This is definitely a unique experience, and all of us have a learning curve. So I just really wanted to mention to everybody that's in attendance, there's a wealth of information in the virtual exhibit hall. So I welcome you to join the booths. Another question that came in is, how were the work teams in the cases shown formed? What knowledge did they need to have to use the products described?
Yeah, it's a really good question. Management of change is probably one of the most important things when you start venturing into new areas of innovation, right? And so, as I mentioned in the slides, is you know, this was a tool built by process and control engineers for process and control engineers, right? So Typically, the teams that were part of these projects, they consisted of process engineers that intimately know the plant. So they need to bring their domain expertise. We do have some people from the central team. That'll be maybe a data science team that are driving these projects more from a corporate perspective. And then we might even pull in some of the process operators who work with the process on a daily basis. In terms of whether they are able to actually then take the product and run with it, yes, absolutely. We have plenty of success stories where the process engineers do a training course with us. It's like 2-day, 3-day training course, and then they go on their way. And they might need some expert coaching along the way, but the workflows are set up in such a way that they add value like immediately and not just over, after a year or two.
Yeah. So, okay, can I ask another question? That you bring me to a good point. So you're talking about work processes, and obviously you have a methodology to address this for plants. Is there something unique or something that you can share with the attendees about how you're able to do this when sometimes people aren't working in the same place? And we heard about that during the keynote today, that one of the, the biggest advantages of COVID-19, it was 2 years of acceleration in 2 months. So are you still doing projects even though, there's people working from home, separation at offices?
Yeah, I'll take that and I'll hand it over to Bernd. Absolutely. I would say that, as was mentioned in the keynote plenary, everything has changed. There were some folks like us that were very much prepared and ready for this change, but we noticed that some customers were a little hesitant. They had to get comfortable with this idea of remote project execution, and surprisingly, they adopted very quickly. It didn't take many cycles for them to recognize that things could be very efficient, could move very quickly. The agile environment actually worked. These technologies actually worked, and they were able to see this upside from their operations. And what we heard earlier about this snap back to the norm, I don't know if a lot of that is going to happen. It is a legitimate fear that we also see, that customers are going to very quickly want to get back to the way that they were doing business. But we have been able to exceed even our own expectations around being able to execute in this remote fashion. But that said, there is something about being with a person, being face to face with them and working with them, person to person, that I think all of us are longing to get back to at some point.
Yeah.
Bernd, I agree with you, Chris. Sorry, can I quickly give an answer there?
Yes.
So I have a couple of customers that I'm working with right now remotely. Some send me a laptop, some work on our cloud machines that we provide to them to access, and some install an extra computer in their control room so that I can access that computer without bothering them. So it's all about where you are in your digitalization journey, and we're very creative in the way that we're trying to meet the needs, right? And it's been very successful.
All right. So there's no other questions. That means the analyst from ARC gets to ask another question. And I'm just, going back to the title of this session, zeroing in on process health. AspenTech seems to have a unique message here. It's, you're talking about asset health, you're talking about availability, and you're also talking about process health. What about AspenTech is unique in this business? Chris, maybe I'll go to you first.
I think it's that it's really understanding that there's dimensions to success, and there's the asset dimension, there's the operation and process dimension, there's the human expertise dimension, there is the technology dimension, and then there's the wrapper around all of that, which is the change management dimension, because these things are in flux. None of it's static, and there are factors outside of us, from weather to climate change to social stresses and pressures. All of these things have an input into our end results. And so when we put together these programs, we build them specifically at AspenTech to anticipate these changes. such that what's required to keep things moving forward is very, very minimal. So I would say that that is a part of the DNA of who we are as Aspen and AspenTech, and how we deliver to our customers and stay very close to them throughout that journey.
Okay, listen, we're almost out of time. So maybe Chris, Bernd, if you could just give us, you know, a quick wrap up, you know, advice to companies to help them reduce downtime going forward.
Bernd?
Yeah, so I think my advice would be, remember your asset health is not a function only of the risk the risk model that you're using. It's not only a function of your equipment breaking down, it's also a function of your process. In fact, those three parts of the operating business need to move closer together, and AspenTech is really here to help you achieve that.
Thanks, Bernd. How about you, Chris? Any final comments?
Just that this effort that we're embarking upon now at this time is really focused on the environment, sustainability, and the circular economies. Again, keeping people safe, obviously protecting the equipment and the processes, and doing that faster and cleaner.
All right, gentlemen, thank you very much. We've really enjoyed the session. Really appreciate it. And if you have any questions, please look for Chris and Bernd over in their booth. Thank you very much.
Thank you, Peter.
Thanks.